Welcome all. So today we are going to learn all new features in C# 10, which will be the part 3 and the conclusive part, and what are the contents. This will be a more exhaustive part as compared to the part 1 and part 2, and we will discuss most of the important stuff here that we have left. That is the extended property patterns, improvements on lambda expressions, allow const interpolated strings, record types can seal to string, improve definite assignment, caller argument expression attribute, assignment and declaration in the same deconstruction. And I will have all the code available that we'll be working through in this session in my blog site, which will be down there in the description of the YouTube video. Feel free to view the blog also along with this video, and also you can jump over to the portion that interests you through the indexing that you have available on the timeline in the video. So let's switch over to the first part, which is the extended property patterns. Now I have switched over to what's new in C# project that we have left in the part 1 and part 2 we have built on this project, and we'll continue building our new features on this. Now what I have done is I have to use in this global using statement, which I have already introduced earlier in one of the parts, probably the part 2. I will use this global using because I'll be using this namespace, this project, what's new in C#. Okay, so it comes automatically on the mouse over. So I'll be soon explaining the fact, and I'll be exclusively using top level statements rather than actually writing different classes and making them as entry point, because I feel this is easier to follow and do for the rest of this particular video with all the features. So what I will do, I have already used the using statement in that global using statement, and then I'll no more need to use it. So let's see what's the extended property patterns. Now pattern matching was introduced in C# 7 and has been improved in every major language version since then. Now C# 10 is no exception, and it makes it possible to use more concise property patterns. For instance, before C# 10 you wanted to check nested properties in a pattern, you had to write something like this. Now for this example to be followed, I have to create add a new class. So click on add class, name this class as employee class, and this employee class will have just 2 properties so that I can follow some of the stuff that I wish to today. So employee class will have I'll keep it internal, by no need to make it public or private or anything, because internal class is as internal keyword in C#. If you are aware, internal keyword makes it visible to all the classes within this project. Okay, so just 2 properties, first name and last name. So public, let's make it string. First name gets set. Make this last name. And then a public constructor which takes 2 parameters, string f name L name where this two properties, first name is assigned f name and last name L name. Okay, so this is also one of the features of this Visual Studio 2022, which actually suggests the code for you, and sometimes it works and sometimes it doesn't, but it goes a long way to show the improvement with the Visual Studio 2022. The Visual Studio ID has come of age, and this is all done internally by artificial intelligence. Okay, so that's enough our topic of discussion today. So what we'll be doing next is we'll come back to program class, and then we'll start coding. Now this is what demonstrates this part, first name dot length colon greater than 10. This is the extended property pattern. Earlier till C#9, this was available if employee is first name colon within a pair of curly braces, length colon greater than 20. Now this was a little verbose. It was a bit untidy, and this is much simpler to understand and write. So this is the extended property pattern. Okay. Now if you click on this, if you run this application, all this brings is that name is not that long, because the first name property has got less than 10 characters. Okay, so if you, this is pure C#, so I don't need to go into how to get to this first part. It is a long name. Just if you write a little bit more number of characters instead of Jackie, some name which has got more than 10 characters, it will be a long name. So that was the extended property pattern. Now what is next? Now bear in mind the earlier way of writing till the C#9, this when the extended property was not there, property pattern was there, this will also still be working. So if you just uncomment this and comment the revised version, it will still run and give the same output. And this is because of the backward compatibility of any programming language, and C#10 is no exception. Okay, so name is not that long. All right, so let's move on to Lambda improvements. Now C#10 includes many improvements to how Lambda expressions are handled. Now Lambda expressions may have a natural type where the compiler can infer delegate type from the Lambda expression or method group. And Lambda expressions may declare a return type when the compiler can't infer it. And attributes can also be applied to Lambda expressions. Now these features make Lambda expressions more similar to methods and local functions. They make it easier to use Lambda expressions without declaring a variable of a delegate type, and they work more seamlessly with the new ASP.NET Core minimal APIs. Now what is automatically, we have talked about automatically inferring a natural type for Lambda. Historically, C# Lambda expressions didn't have an intrinsic type. So the expression, now this expression I will write. Now let's write a comment. So what I was telling about, I mean, if you have got a statement Lambda expression like this, int of n within circular brackets, this is the Lambda operator, n %2 equals 1. So this didn't have a type of its own. Now this, so what this squiggly line says, only assignment, call, increment, decrement, await can be used as a statement. But if it didn't have a type, and the type was determined based on what it was assigned to. Okay, basically if you write it like this, and this was then valid, because here this func type, int bool, and you are calling this as a is odd, and then assigning it to this expression, this was valid because the type was determined based on what it was assigned to. Because this expression as it is has no validity, as you have seen. And now this expression on the left hand side, it is assigned to isodd function, which takes two parameters, int and bool, and that is determining its type. Okay, so again, if you uncomment this, this will come to be what you can see, only assignment call increment decrement can be used as a statement. So this is not a statement at all, okay, because it could not determine its type. Now with the Lambda improvements in C#10, now the compiler will try to automatically infer a natural delegate for a Lambda, making it possible to use var to make the code more concise and readable. So instead of this statement func int bool, if you write like this, that's also valid. Var is odd. Oh, this is already there, so that's fine. I can just comment this, and this will build. This will be no squiggly line. So this is the improvement, one of the improvements. All right, and there are other examples. Like another example is this. Again, this lambda operator, string s goes to int dot parses. Okay, so this is also acceptable. Now the compiler can infer pass to be a function of string or integer, func string integer. The compiler chooses an available func or action delegate if a suitable one exists. When a lambda expression has a natural type, it can be assigned to a less explicit type, such as system.object or system.delegate. What I just said is, less explicit type, like, object or delegate. So this could be actually because parse is already there. So this is parse, or so you can write like this or like this. Okay, so here it can be assigned to a less explicit type, such as system.object or system.delegate. Okay, because it has got a natural type. And this is also function of string and int. It's function of string and int. Okay, right. Now method groups, that is method names without parameter lists with exactly one overload, have a natural type. So what I mean to say is like this. So since write has got multiple overloads, you cannot write it like, assign it to the left hand side as var write, because it has got multiple overloads. It can't choose between which it is. But this one, console.read, it has just one overload. So function of integer is inferred. Okay, so it says on the mouse over, the delegate type could not be inferred. Whereas this method group, because this has got only one overload, it can be assigned to a read variable. Whereas this cannot be assigned to a write variable. Okay. The next is explicitly specify the return type of a lambda. Now C#10 makes it possible to specify a return type for a lambda. This wasn't necessary before, since a lambda had to be assigned to a specific delegate type anyway, but with natural delegate type inference, there might be cases when you want the return type to be different from what is automatically inferred. For instance, when I write like this, okay, so here these two are variables, 1, 2, 3 array. Okay, so this is a new array of integer. Inferred type is function of integer, int array. New array with these elements 1, 2, 3. But if I assign this another variable var 1, 2, 3 list as ilist, ilist of integer, and given with the same definition as new array with these same elements 1, 2, 3, it has got the same body. Basically these two, this one and this one, they have the same body, but inferred type in this case is function of ilist integer type. This could be necessary sometimes, and then thirdly, apply attributes to Lambda expression. So how you can do? This is purely for reasons, metadata reasons. You might assign an attribute. Attributes on Lambda expression require a parenthesized parameter list. Okay. Parenthesized parameter list. So this will be all right if let me parenthesize it with a pair of that's all right. So pair of circular braces makes it work. Okay, so the squiggly line is gone. So this is also one of the improvements, adding the ability of adding an attribute. Okay, next we take constant interpolated strings. Now before C#10 it was possible to concatenate strings. The string interpolation functionality existed, but didn't allow to have interpolated string constants. So basically note this point, string concatenation was obviously allowed and string interpolation functionality also existed, but it was not allowed to have interpolated string constant, which is now possible with C#10 for readability reasons. Now let's take an example with C#10 when constants were concatenated. Now let me paste another piece of code, and this is the example of constant interpolated strings. So now as you can see, these are all constant string, scheme, login URI, home URI, and then another constant string dev. Now here I'm allowed to use this $sign, that is string interpolation. Now if you use the earlier version, and just to check, if you change the version to 9 along with many other issues, this will also come up. Let's see. Now I have changed the version to 9 here. Okay, so you can see that there are so many build errors, and this red squiggly line over here in the constant string, it says that feature constant interpolated string is not available in C#9. Please use language version 10 or greater. Okay, so let's get back to making it language version 10 and then save it again. So all these squiggly lines will be gone. If you wait for a few seconds. All right. The next feature that we are going to discuss is record types can seal to string. So in C#10 you can add the seal modifier to the ToString method in the base class, which when you attempt to override in a derived record type ends up in a compile error. Now sealing the ToString method prevents the compiler from synthesizing a ToString method for any derived record types. A sealed ToString ensures all derived record types use the ToString method defined in a common base record type. Now in order to prove our point, I'll paste this code. So this is a public record person, okay, and I am sealing the ToString method public sealed override string ToString, and in order to prove my point that if it is sealed in the base class, in the derived class, it cannot be overridden. So what I will do is I will copy the code and on my clipboard, and just to save time again, so this student record is deriving from the person record, and here I am trying to override string ToString method which has been sealed, and straight away you can see that student.ToString cannot override inherited member person.ToString because it is sealed. Okay, so if you don't seal it, obviously you can override it. You can override it. And let's see if you change the version, what happens. So if you change the version to 9 again, save it. So you cannot use the keyword sealed at all. The feature sealed to string is a record is not available in C#9. Straight away it says on the as a compiler on a squiggly line that please use language version 10 or greater. The feature sealed to string in record is not available. So if you change the version again, it will be all right. So now you could seal it in the base class, but you cannot still override it in the derived class. Now next is another feature called improved definite assignment. Now C# produces errors if you use a value that has not been definitely assigned. C#10 understands your code better and produces less spurious errors. These same improvements also mean you will see less spurious errors and warnings for null references. Now prior to C#10, there were many scenarios where definite assignment and null state analysis produced warnings that were false positives. These generally involved comparisons to Boolean constants, accessing a variable only in the true or false statements, in an if statement, and null coalescing expression. Now this one, I don't have a particular scenario that I can discuss it with, so we'll move over to the next part, which is caller argument expression attribute. Now the new caller argument expression attributes lets you capture the expression passed to a method as a string. Now I will now switch over to Visual Studio 2022 and start working with our program class again to prove my point. So below the last piece of code, I will paste this static void log expression checking caller argument expression attribute. So what it says, the top level statements must precede namespace and type declaration. So basically this means I'll have to put it above this part. I will just take the whole piece of code, cut it from here, and so I have put the entire clipboard content here just above the start of the class, demo class. And what it does is that this caller argument expression, it allows capturing of the expression passed to a method. Okay, now what happens if you run this application once again? Let's see. We always believe in action, don't we? No, what is the problem? Okay. Oh, cannot override. Oh, sorry. I'll have to check this, comment this. So it brings the code, the person.firstname Thomas below the earlier, console.writeLine statement. So what happens here? Let's see. This expression parameter, okay, this parameter is optional, And if it is not specified, then the compiler will automatically pass the expression used as the value parameter. Now here I am calling var person and I am initializing new employee and passing the first name and last name. Now in other words, the call to log expression with the first name value and expression, if it is null, is actually writing like this. This will also bring the same thing if you build it. So see, person.first name is Thomas. So whether you write like the first way or the second way, if the second parameter is not passed, this is automatically taken as the expression used as the value parameter. So a common use case is a method that checks that an argument isn't null. So what we will do is I will paste this code below. Okay, so I will make a static method foo which takes a string name, and if you pass a value of null instead of a particular non-null value, then let's see what happens. Okay, so if you pass a non-null null value, and if you try to build the solution, so rather if you run this application, let's see what it brings. So as expected, this brought the unhandled exception, value cannot be null, parameter name. Now if we build this application, if we run this application, this brings this system.argument null exception, value cannot be null, parameter name. Let's close this window, and with this let's move to the next one, which is assignment and declaration in the same deconstruction. Now what is deconstruction? Same deconstruction of a record or a tuple. So I will be discussing the tuple. So C# features a built-in support for deconstructing tuples, which lets you unpackage all the items in a tuple in a single operation. Now let's now see what is a tuple. A tuple provides a lightweight way to retrieve multiple values from a method call, but once you retrieve the tuple, you have to handle its individual elements. Now beginning in C#10, you can mix variable declaration and assignment in a deconstruction. Let's again switch back to this program file, and I will paste this code. Now I will paste this code. This is another class I have built within the program class, example class. So this is a tuple. What it does is that it takes a string name, query city data, and it actually outputs a string, an integer, and a double. So what happens in the body, if name equals New York City, return name, and this is a digit and this is another digit, whatever it means, let it mean population, and this one is area, and we can get these from here. Okay, so how it is called? String city, say if I call the city as relay, in population is this, and I can call this. This is the change that has been done. This is a deconstructing. This is a tuple or tuple, and this is deconstructing a tuple. Okay, by calling this tuple, this is actually, we have already assigned these two values here, the city and the population, but we have not assigned the value to the area, but we are actually doing it in the third line over here. This is assignment and declaration in the same deconstruction. Now to demonstrate the get tuples, I'll have to call this. So example dot get tuples from outside. Okay, get tuples, what it says, top level statements must precede namespace and type declarations. So again, can give it, let's see if it accepts it from here. Okay, right, example.getTuples. So what will you expect? Console.write line city, population and area. So if the name is New York City, then you return name. If it is not New York, like Raleigh, so it will return Raleigh, and population is this, and area is the same one. Okay, so let's run this application. So before running this application, I have to comment this out, otherwise it will come up with this argument null exception. So if you now run this, so you get this output, New York City, this one, this data is whatever it is, population, and this area. But if I had fed it like this, you know, if I, instead of calling query city data and giving it New York City, if I had fed just a city, which is the city Raleigh, it will change the equation. And if you build this, if you run this application again, so it gives you just empty space, you know, white space, 0, 0, because the name was not New York City, it was just city, which was Raleigh. So this is sort of else statement, it falls to this else branch. If name equals New York City, you know, this is the return, otherwise the return this. All right, so with that we have effectively finished this lesson, and we have revised these things again. So one by one we have seen extended property patterns, improvements on lambda expression, allow const interpolated strings, record types can seal to string, improve definite assignment, caller argument expression attribute assignment and declaration in the same